Hello, everybody. We're back with composite function. We're just look at one more example using domain. So in this problem, we're given f of g of x, and we're told that f of x is 1 over x plus 3, g of x is 1 over x minus 10. Two ways to think about this problem. The way I want to think about it is I just want to compute and find f of g of x. So the idea here is to find f of something first. That's going to be 1 over something plus 3. This is taken directly from f of x. And now what I want to do is I want to substitute in my g of x value. So my g of x value is given to me over here. And let's just make this let's make it easy to look at. We're going to do it. And we're just going to change some colors here real quick. So what I want to do is I want to take that g of x and I want to plug it in here. And instead of plugging g of x in on this other side as well, we're going to actually plug in what g of x is equal to. So we're going to plug in that 1 over 10, x minus 10. So this is our function f of g of x. It's a complex fraction. I would prefer that we did a little bit of work here to simplify this. So what we're going to do is we're going to end up with 1 over x minus 10 all plus 3. Now, the way I prefer to do this problem is what I like to do is I like to get a common denominator down on the bottom. I'd like to just take a moment and do as a side problem, okay, 1 over x minus 10 plus 3. And I'm going to replace the denominator with that. So to do that, all I've got to do is find a common denominator. That means I need to get an x minus 10 on the bottom of this expression, which means I'll need an x minus 10 on the top. So if I multiply the 3 by x minus 10 over x minus 10, I'll end up with my original fraction, 1 over x minus 10. And then my second fraction, when I distribute, is actually going to be 3x minus 30. And that's all over x minus 10. So when I combine these guys, I get one denominator. And that's the key when you're dealing with this, having one single fraction. X minus 10 on the bottom, and then 3x minus 29 on the top. So now I'll go back and I will replace this entire denominator with what we just found, because that's where we start. We combine those two terms. So that means this entire function is now equal to 1 over 3x minus 29 over x minus 10. But now I've got division by a fraction, which really just means in this case 1 over. I'm taking the reciprocal of that bottom fraction. So it all turns out to be x minus 10 over 3x minus 29. So this is what f of g of x equals. Now, if I'm talking about domain, I'm looking for the bad things. The only bad thing here is when the denominator equals 0. So I'm going to take 3x minus 29. I'm going to set it equal to 0. And by solving that, I'm going to get that 29 by itself, and that's going to give me x equals 29 over 3. This is the bad thing. Okay, this is bad. So that means we're going to kick him out. That means our domain is going to be from x starting at negative infinity going until 29 over 3, and then starting again on the other side of 29 over 3 going until infinity. This would be the final answer we're looking for this particular example. So one way to do it is just to go and directly find f of g of x. Compute it directly, make it a single function, and then just look for the bad things. We could have done this one a little bit differently. We could have tackled this one in another way. We could have said, okay, look, what bad things does f of x have? And for that, we're going to get that x can't equal negative 3. Okay, so if x equals negative 3, the denominator here is going to equal 0. We can just kind of look at that by saying, when does that denominator equal 0? And that means when x plus 3 equals 0. And that's how I got that x equals negative 3. Now, if you remember how this works, we're talking about taking the x, plugging it into g first, and then that output becomes the input of f. So what we're saying is we are in danger if we ever see x equaling, or it's going to be, if we ever see a negative 3 coming here. So this is the output of g of x on this side, but it's the input of f of x on the other side. We know if negative 3 is the input of f of x, we got trouble. The only time that can happen is if negative 3 is the output of g of x. So we could now take this information and take it to g of x, and we could just ask, when does g of x equal negative 3? Because wherever that happens, f of x is going to get the output that causes trouble. So solving this, we're going to get 1 over x minus 10 equals negative 3. What I'm going to do is I'm going to multiply both sides by x minus 10, and I'm going to get 1 equals negative 3 times x minus 10. That will clear the denominators. Okay. Then we're going to get 1 equals negative 3x plus 30. From here, I'm going to subtract 30 from both sides. And then I'm going to divide both sides by negative 3. We're going to end up with 29 over 3 equals x. So again, this is the bad thing. That means our domain is negative infinity to 29 over 3. And then again from 29 over 3 to infinity. Okay, so both methods are perfectly valid. The first method, you just find out what your function is directly, and then you find the domain of that directly. The second method relies on this idea again. So we find out what's going to cause trouble going into f of x, and then we make g of x equal to that. So whatever causes trouble for f of x is what we make g of x equal, and that's where it's going to find the domain. Another way to say that is whatever the outside function is, wherever the outside function has trouble, find out when the inside function equals that trouble, and that's going to be kicked out of the domain. I hope that makes sense. I'll be talking to you soon. Hope you're all having a good weekend. Take care, and let me know if you have any questions at all.